Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 11 Physical Sciences Redox Reactions. Today, which is the third video, we are looking at balancing redox reactions. Remember, we promised you that we will have a video where we're balancing redox reactions, right? Well, this is the video. Right, this is the video. So without any waste of time, let's get into it. So we are going to, I'm going to do this. I'm going to say, this will be examples. So I'm going to say, balance the following redox reactions. Okay, balance the following redox reactions. I will begin with the example we gave in the first video, which is zinc solid plus copper 2 plus aqueous phase, giving us zinc 2 plus aqueous plus copper solid. Number 2 will be zinc solid plus silver plus aqueous, giving us zinc 2 plus aqueous and silver solid. Number 3, we will try NO3 minus aqueous plus Fe solid, giving us NO gaseous phase plus Fe2 plus aqueous. Okay, and then should I add a fourth one? I think I should add a fourth one. Right? I think I should add a fourth one, but I don't know. Okay, the fourth one that I'm gonna add is this. It's gonna be, let me see. I think I should try this one when it's given in writing. Okay, I'm gonna say silver 1 ions oxidize. Okay, silver 1 ion oxidize cobalt 2 plus ions, oxidize cobalt 2 ions. All right. In the reaction, I'll go to the next page. In the reaction process, or in the process, let me say in the process. Silver ions, to be precise, silver 1 ions are reduced to silver. Write the balanced equation. Write the balanced equation. And I think I should also try, will we have, I don't want this video to be too long, but in fact, let's be fine. I think we should leave it here. Not enough. I'm not happy. Yeah, I'm not happy. Let's add this one. Number 5, we'll try HCl aqueous plus MnO2 solid, giving us Cl2, okay, giving us Cl2 plus Mn2 plus aqueous. Okay. I think this is better. Right? I think this is better. All right. Now let's see. So our solutions, let's see now. Our solutions. The first one is zinc 2 plus blah blah. So let's see, zinc 2 plus, I'm going to write it. It was zinc, zinc 2 plus, no, it was zinc solid plus copper 2 plus aqueous, giving us zinc 2 plus aqueous plus copper solid, isn't it? Plus copper solid. I believe this is what we had. All right, this is what we had. Okay, perfect. Now what we do, we will take zinc solid. As you can see, it's also giving us zinc 2 plus aqueous. All right, it's also giving us zinc 2 plus aqueous, isn't it? So now we need to balance first thing first the elements. Are they balanced? Yes, we have one zinc on the reactant, one zinc on the product. They are balanced. But the charges are not balanced. This is 0 charges and this is 2 positive charges. So we need to add how many electrons? 2 electrons. Now this is balanced. As you can see, electrons are on the product side. So this is oxidation half. Alright, so this is oxidation half reaction. Now let's look at the copper. Copper 2 plus aqueous. Let me just leave a bit of a space, plus copper solid. So the spaces copper are balanced, but the charges 0 charge, 2 charges. So we need to add 2 electrons so the charges are balanced. As you can see, electrons are on the reactant. So this is reduction half. Right? This is reduction half. So if you were to find overall reaction, you will need to, say, maybe let's try this. Whatever that is the same on the reactant and product will cancel. If it's on the reactant of one side and reactant of another side, they will cancel. For example, this guy will cancel with this guy. What are you left with? You are left with zinc solid plus copper 2 plus aqueous, giving you zinc 2 plus and copper. What? And copper, what is this? And copper solid. Now these equations, as you can see, they are balanced. The elements, so for this one, I just wanted us to get the oxidation part of it. The elements are balanced, okay? The elements are balanced and the charges are also balanced. So this, we did not need to balance it in any way, but we had to give this oxidation and half reactions, okay? So perhaps we should say balance the following and also give half reactions. Maybe I should say also give half reactions. Okay, maybe I should also say also give half reactions. Okay, perfect. So this one is balanced. So let's get to number 2, zinc. I'll always come back to it. Number 2. What was it? What was number 2? Number 2 was it was zinc solid plus Ag plus. Okay. Zinc solid plus Ag plus, I believe aqueous. Right. It'll be aqueous, giving us, I believe it'll be zinc 2 plus aqueous plus Ag, which is silver solid, isn't it? Ag, which is silver solid, right? Let me confirm. Right. So as you can see here, the charges are not balanced. But if you were to do this, the spaces are balanced, but the charges are not balanced, right? The charges are not balanced, but the spaces are. So if I were to balance this, I will simply say if I add 2 here, I do see the charges. We have 2 positive charges. 2 positive charges are balanced. But the silver is not balanced. So this is the reaction balanced. Now let's try to get the half reaction. Okay. Now let's try to get the half reaction. Proceeding. So the half reaction for this one will be, let's try zinc solid giving us zinc 2 plus. As you can see, they are balanced, but the charges are not. So we might need to add electrons. This is your oxidation half. I'm saying oxidation half reaction because electrons are on the product side. Now we need silver, aqueous, leave a space, to silver solid. So the spaces are balanced, but the charges are not. So there's one charge, and to balance the charges, I will need to add one charge on the electron. So what is this? This is the reduction. All right, this is the reduction. So to now get the overall, what I will need to do is this. I will need to do this. To get the overall, I will say zinc solid, giving us zinc 2 plus. I forgot to add aqueous there. Plus 2 electrons. I then multiply this by 2. When I multiply the reduction reaction by 2, it will be 2 Ag plus aqueous plus what? Plus 2 electrons will give us 2 Ag solid. Now, as you can see, electrons are cancelling. What do we have? We have zinc solid plus 2 silver plus ions, giving us zinc 2 plus, or zinc ions plus 2 silver solid, right? Plus 2 silver solid. Happy? Perfect. All right. So now let's see what equation 3 was. Rather, question 3. Okay, question 3. Okay. Get it? Question 3. Question 3 was, now this is when it's getting interesting now. Question 3 was, NO3 minus in aqueous phase plus Fe solid will give us NO in gaseous phase plus Fe 2 plus in aqueous phase. So I will begin by balancing the ions, Fe. So I see Fe solid will give us Fe 2 plus. So what do I need? I can balance, as you can see, the species are balanced, but the charges are not. 0 charges, 2 positive charges. So let's add 2 electrons. Now these are balanced. What is this? Electrons are on the right side. So since they are on the right hand side, this becomes oxidation half. Now to balance this, it will be interesting. It will be interesting. I want you to follow the steps. I want you to follow the steps, guys, okay? I want you to follow the steps. So what we need here, I'm going to say this. First thing first, I'm going to say balance oxygen, add water to the product. Add water to the product. Okay? Balance oxygen, add water to the product. So what do we do? This will be NO3 minus will be NO plus H2O. How many oxygens do we have on the reactant side? We have 3. On the products, we have 2. All right? So what we can do to balance the oxygen, we'd rather add a 2 here. As you can see now, the number of nitrogens are balanced. The number of oxygens are also balanced. 1 oxygens, 3, and this is 1 and 2. So this is 3. Oxygens are balanced. Now balance hydrogen. Okay, now balance hydrogen. You follow these steps, guys, okay? Now balance hydrogen. Add H plus in the reactant. Okay, add H plus in the reactant. Okay, so what is this? This was NO3 minus, it was aqueous plus, I'm going to say H plus, of course it's aqueous, giving us NO, it's gaseous, plus I think we said 2 water molecules, liquid phase. Now let's balance the hydrogens. How many hydrogens do we have on the product? We have 4. Here we have 1, so it must be multiplied by 4. Now, as you can see, all the species are balanced, but the charges are not. In total, we have minus 1 plus 4 charges, which is 3, but we have 0 on the reactant. So we must balance the charges. So let's go. So now balance the charges. Okay, when we balance the charges, let's see. On the reactant, we had, let's see, NO3 minus aqueous plus 4H plus aqueous. So we need the left-hand side. We need the left-hand side to be 0, to have 0 charges. So minus 1 plus 4 is positive 3. So it seems we need 3 electrons. All right? Okay. Now this is balanced. All right? Now this is balanced. As you can see now, electrons are on the reactant side. So this is a reduction half. Okay, this is a reduction half. Okay, this is a reduction half. So let's remind ourselves what we had earlier. Now, when we balanced, we had iron. Okay, let me rewrite this. We have this guy, NO3 minus aqueous plus 4H plus 3 electrons, giving us NO. You are also aqueous body, NO gas plus 2 water molecules, liquid. Now we have, I believe we had iron. It was solid iron, giving us iron 2 plus aqueous plus 2 electrons. Now I want you to see this. The electrons are not balanced. Now since the electrons are not balanced, we have 3, we have 2. We'll need to multiply this. We will need to multiply the first reaction by 2, and then we have to multiply the second reaction by 3. So what is this? This becomes 2. Now what is 4 times? What is 4 times 2? It is 8. 3 times 2 is 6. 2 times 1 is 2. 2 times 2 is 4. And then here it's 3, and here it'll be 6. Now what is the overall reaction? The overall reaction will be 2 nitrate aqueous plus 8 H plus aqueous. As you are aware, the electrons will cancel, plus 3 Fe solid, giving us 2 NO gaseous plus 3 Fe3 plus aqueous plus 4 water liquid. Right? Now there's something that I want you to see. You can leave your reaction here, okay? You can leave your reaction here, or you can try to balance. Here you have nitrate and you have hydrogen ion. Oh, this can give you nitric acid. So you need 2 hydrogen ions combining with nitrate to give you nitric acid. Right? Let's go now. What is this? So this then becomes HNO3. HNO3. It's going to be 2 of it. Plus, you have removed 2 hydrogen ions. You are left with 6. Plus, this will be, let me call it aqueous, and this will be 6 hydrogen ions, aqueous, plus what? Plus 3, okay, plus 3 solid iron, giving us nitrogen monoxide gas. Let me see, it was 2. It was 2 plus 3 iron 3 plus ions aqueous plus I think it was 4H2O liquid. So you can also leave it like this. So guys, this step, it's important that you follow it. It's important that you follow this step, especially for this part. It's important that you follow it in this manner that I gave you. Okay. And to be honest with you, this is something that you will need for grade 10, for grade 11, 12, and so on, if you are going to venture into chemistry, chemical engineering, metallurgy. Okay. Perfect. Now let's see the fourth. The fourth says silver ions oxidize cobalt-2 ions. Now to say they oxidize cobalt-2 ions, we need to understand what is undergoing oxidation is cobalt-2 ions. Okay. What is undergoing oxidation is cobalt-2 ions. Okay. So silver ions oxidized cobalt-2 ions. Okay. In the process, silver ions are reduced to silver. Okay. In the process, silver ions are reduced to silver. All right. So let's see now. If silver ions are reduced to silver metal, what is this? This is example number, I believe, 4. It would be, so we know silver, you are being reduced. If you are being reduced, there will be 1 plus an electron giving us this guy. So this is silver, not silver ion, solid silver. Okay. All right. This is it. Now cobalt. Now, remember the statement said this silver ions are oxidizing cobalt-2 plus. So if they are oxidizing this, so what that means is that we could be having something like this. Cobalt, solid, giving us cobalt-2 plus, plus. Now we need to balance the reactions, the charges. 2, as you can see, this is a reduction. All right? This is a reduction, half reaction. And what is this? This is oxidation. Ooh, this is oxidation, half reaction. Okay. This is oxidation, half reaction. Okay. All right. This is it. I'm not sure if there's something that I missed. Now let's try number 5. Number 5. Okay, I'm going to write it. I saw it. I think I also wrote it down as well. Let me start here. Number 5. Number 5, what do we have? Number 5, we have hydrochloric acid aqueous plus, we're going to call this guy here NO2 magnesium oxide, or manganate. Not magnesium. This is manganese. It's a solid phase, giving us chlorine gas plus manganate 2 plus ions aqueous. So this is chlorine gas. Okay. We can do now is this. Let's see. Hydrochloric acid with Cl2. This is very interesting, right? This is very interesting. Now, this is an acid-base reaction. So this means it is increasing the concentration of H+. So it'll become what? It'll become, to balance the, let's try to balance the chlorines, 2. Now let's balance the hydrogens. When you balance the hydrogens, it'll be plus H+. How do we balance them? 2 plus, isn't it? Or maybe let me start like this. Balance the species. Balance the species and add H+ on the product. So to balance the hydrogens, right? So what do we do? To balance the species, we'll say chlorines, let's balance them. Now the chlorines are balanced. To balance the hydrogens, because this is an acid, it increases concentration of H+. It'll be this guy. Now let's balance them. It'll be 2. Now what do we do? Balance the charges. Because now species are balanced, we balance the charges. Alright? we balance the charges. As you can see, each and every species is balanced. Now let's balance the charges. There are 0 charges on the reactant and 2 on the product. So this means we need to add 2 electrons. So 2 HCl, let me add the species, the phase, equals, giving us chlorine gas, plus 2H plus equals, plus, to balance them, to balance the charges, I will add 2 electrons. Isn't it? To balance the charges, I will add 2 electrons. Happy? Perfect. Now, MnO2 and Mn2 plus. Let's go. MnO2 solid and Mn2 plus aqueous. Now, add H2O on the product. So to balance the oxygen. Okay. In other words, balance oxygen. Okay. So what do? We say MnO2 solid, giving us Mn2 plus aqueous. We're going to add water, H2O. Now what do? Let's try to balance them. It'll be, to balance this, we add 2. Now what do we do now? You balance hydrogens, okay? Balance hydrogens, right? Balance hydrogen, add H plus, right? Add H plus on the reactant side. All right, on the reactant side. What do we do now? We say this is MnO2 solid plus hydrogen plus aqueous, giving us Mn2 plus 2HO, your aqueous, plus 2H2O liquid. Now let's see, balancing the hydrogens, we have 4, we have 1, so it'll be plus 4. Now, we have 4 charges on the reactant side and 2 positive charges on the product side. So, balance the charges. So, when we balance the charges, let's see now, when we balance the charges, what do we have? We will need to add 2 electrons, I think, on the reactant. Right? Plus 4, H plus ions, equals, of course, plus 2 electrons will give us Mn2 plus aqueous plus 2H2O liquid. Now, as you can see, the charges are balanced, right? The charges are balanced. Let's go back to check previously what we had. Now we can find overall. What did we have? We had, let's see, we had 2HCl aqueous, giving us chlorine gas, plus 2H plus 2 electrons. Oh, your aqueous. And then we had MnO2 solid plus 4H plus aqueous plus 2 electrons, giving us Mn2 plus aqueous plus 2H2O liquid. Right. Now, I see the charges are, the electrons are balanced. So this cancels with this guy. And then this, there are 2 here on the products. Or let me change the color so you guys can see. And there are 2 here. And then it'll cancel 2 of here. And you will be left with 2. Now let's see what you have. Okay. Now let's see what you have. Now this means that overall what you have now is you have 2 hydrochloric acid aqueous phase plus MnO2 solid phase plus 2 H plus ions aqueous, giving us Cl2 gaseous phase plus Mn2 plus aqueous plus 2H2O liquid, right? Plus 2H2O liquid. This is now you balancing the redox reaction. As you can see, the charges in this overall reaction, the charges are balanced, the spaces are all balanced. Hydrogens 2, 2, it's 4, 2 times 2, 4. Hydrochloric, chlorine 2, 2. Manganese 1, 1. Oxygen 2, 2. Balanced, right? So this is it, guys. This is how we balance redox reactions. Remember, we were also showing which are, what is this? We are also showing which are oxidation and which are reduction. With this one, I think I didn't specify. So with this one, we can see that this one here, electrons are on the product side. Therefore, it's oxidation, right? It's oxidation. Then this one here, as you can see, electrons are on the reactant side, so it is reduction, right? It is reduction. Okay, so these are your half reactions and the overall reaction. Okay, and the overall reaction. So with that being said, ours ends here. And remember, to get in touch with us, visit our website www.ramtasolutions.co.za, and you can contact us if you want a tutor or you want exam preparation. All right, guys. So this is it, and bye-bye.